Alright, now what we're going to look at is this concept called factoring completely. So, we have done 4 different types of factoring. The first type of factoring we did was by factoring out a GCF. Then, the next type of factoring that we did was we looked at a trinomial in the form of ax squared plus bx plus c. And we had 2 different types that we would look at. We did it when a equaled 1, which all we had to do was a factor sum table. And then we also looked at a is greater than 1, where I would have to take my a value and multiply it by my c value, do a factor sum table, and then divide it back out. The third type of factoring we looked at was factoring by grouping. And again, when we did factoring by grouping, the point of doing that was I had to find parentheses and I had to make what was in parentheses match. And then the final type that we looked at was the difference of perfect squares. Alright, but what we're going to look at now is the fact that you might actually be combining more than one of these types all in one problem. Alright, so for example, let's take a look at 36a to the 4th minus 4a squared. Very first thing you want to look at is, well, is there a GCF? If there's a GCF, I want to take it out. So if I look at 36a to the 4th and 4a squared, 4 and 36 are both even, and 36 is divisible by 4, so they have that in common. They both also have a's. So I want to take out my GCF, and my GCF here between 36 and 4 is going to be 4, and between a to the 4th and a squared is going to be a squared. So now when I factor out my GCF, I still have to let you know what's left in parentheses, and so 4 times 9 gives me 36. A squared times a squared gives me that a to the 4th that I was looking for, and then 4a squared times minus 1 gives me the minus 4a squared I was looking for. Alright, before this would be done and I would be over, but when I look inside my parentheses now, I'm not done. I can still factor that as well, because what I have now is I have a difference, because I'm subtracting, of perfect squares, because 9a squared is a perfect square and 1 is a perfect square. So now to finish this problem, I'm going to have to factor what's in parentheses. So I'm just going to bring down my 4a squared because it's still a part of my problem. And this is the difference of perfect squares. So I have to take thing 1, which is 9a squared, and take the square root of that, which is going to be 3a. Then I have to take thing 2, which is 1, and take the square root of that, and the square root of 1 is 1. Now that I have those two things, I'm going to add them and I'm going to subtract them. So this would be my final answer. So again, for this problem, not only did I have to do the GCF method, I still then had to do the difference of perfect squares. Alright, so let's take out another one that's going to combine another couple types of factoring. Alright, let's say I gave you 3x to the 4th plus 24x cubed plus 48x squared. Alright, when I look at this, the first thing I'm going to notice is that there's 3 terms. So I'm going to think to myself, oh, that means I'm going to have to factor by using a factor sum table. Alright, but the only problem is I can't go ahead and do that right away, because if you look over here, my second type, a trinomial, is ax squared plus bx plus c. Well, in mine, I don't have x squared, and I'm also not ending with a constant term. I have a variable in every single part of this. So that means that there's a GCF. So the very first thing I need to do in this problem is I notice that there's a GCF, so I'm going to have to factor it out. So if I look at 3, 24, and 48, numerically what they have in common is a 3. And then they also all have x terms, and the smallest x term is x squared, so that means I have to factor out an x squared. So my GCF is 3x squared. Now, I want to let you know what's still inside my parentheses when I factor that out. 3x squared times x squared gives me my 3x to the 4th. 3x squared times 8w is going to give me the 24x cubed that I was looking for. And then 3x squared times 16 is going to give me that 48x squared I was looking for. Alright, so before I would be done, but now I want to take a look at what it is that I have in parentheses. In parentheses, I have x squared, plus 8x not 8w, 8x plus 16. And when I see that, I notice that now I do have this type 2 that we looked at, ax squared plus bx plus c. My a value is 1, so all I have to do here is my factor sum table, and I want to know what multiplies to 16 but adds to 8. Since my 16 is positive and my 8 is positive, both of my factors will be positive, so I have 1 and 16, I have 2 and 8, and I have 4 and 4. Well, the sum of 1 and 16 is 17, the sum of 2 and 8 is 10, the sum of 4 and 4 is 8, and that's what I was looking for. So my two factors are 4 and 4, so that means that this problem is going to factor to 3x squared times x plus 4 times x plus 4, because again, this part right here was this trinomial factored. So this would be my final answer. Another way I can write it, because you might notice, oh, but I have x plus 4 twice, so x plus 4 times x plus 4 is x plus 4 squared, so you could also write this as 3x squared times x plus 4 squared, and that could also be my final answer. So now this type of problem had to factor both a GCF, and then I had to factor out by using a factor sum table. Alright, let's take a look at an example of one more type where you're going to combine a couple different strategies. Alright, the last one that I'm going to look at, let's say I have h cubed plus 4h squared minus 25h minus 100. Alright, first thing I'm going to do is I'm going to look at this and I'm going to count my terms. I have 4 terms. The only two types I can look at is, am I going to factor out a GCF or am I going to factor by grouping? Alright, well if I look at these 4 terms, h cubed, 4h squared, minus 24h, and minus 100, I'm not going to be able to factor out a GCF because they don't have anything in common. So that means that the only option I have is to do my factor by grouping method. Alright, so when I take a look at this, I have h cubed plus 4h squared. And then here, since my third term is negative, I want to change that to adding the opposite. So now I can also group together negative 25h minus 100. Alright, so back to this first part, h cubed and 4h squared. Their GCF is h squared, so I'm going to go ahead and factor that. So what's left inside is h plus 4. And then when I come to the second set, what I have in parentheses is negative 25h minus 100, so their GCF is negative 25, and then what's left in parentheses is going to be h plus 4. Alright, so now, again, using factoring by grouping, the parentheses that match are h plus 4, so I'm going to factor out an h plus 4, and now I'm going to take what's left over, which is h squared minus 25, and that's going to go in my second set of parentheses. Alright, now I look at my two sets of parentheses. I have h plus 4, that cannot be factored anymore, but then I have h squared minus 25. And I see that and I notice I have a difference of perfect squares. So there's still one more method I can use, and the method I'm going to use is the difference of perfect squares. So my final answer is I'm just going to bring down my h plus 4, and then since the difference of perfect squares, I take the square root of thing 1 and the square root of thing 2, which are h and 5, and then I have to add them and I have to subtract them. So this would be my final answer.